If somebody asks you to multiply these two numbers, and if you're sitting in front of your laptop, you would quickly pull the calculator application, type in the first number, multiply second number, and you got your answer. Quite a useful piece of software application, isn't it? While developing applications like this, programmers generally take care of two things. One, designing the user interface, like this part of the front panel through which user provides information, the inputs, and this part from which he reads the results, the output. And the second is defining the relationship between these inputs and the desired output, which is constructing the logic of the application. Now, these two tasks are generally done using a programming language in some kind of programming environment. As engineers, you surely must have heard of some of these programming languages. Today, we'll learn about a new kind of programming environment called LabVIEW, which is an acronym for Laboratory Virtual Instrument Engineering Workbench. LabVIEW is a little different than maybe some of the other traditional programming languages, in a sense that in those languages, programs are developed by writing lines and lines of text. But LabVIEW is more graphical in nature and hence more intuitive, where coding is done by connecting blocks or connecting terminals. Every program that you create in LabVIEW is called a VI, virtual instrument. So let's jump into LabVIEW programming environment and build some VIs. Once you have installed LabVIEW software on your system, you will get an icon on your desktop like this. You double click on it and it will take you to a getting started window. In this window, you will find an option called blank VI. Click on it and it will bring up two new windows. One is front panel and the other is block diagram. Every VI contains these two parts. Normally you would want to keep these two windows side by side, and to do that, go to Windows option here and click on tiles left and right. So now to the left that you have your front panel and to your right you have your block diagram. The front panel window is the user interface where, like in the calculator example, you place your inputs and outputs. And in LabVIEW terminology, these inputs are called controls and the outputs are called indicators. So if you go to the front panel and right click on it, you will get a palette called Control Palette. You will find various types of controls and indicators under different subcategories. Make a note, though it's called a control palette, it also contains indicators. You will get used to these subcategories as we'll build more and more VIs, virtual instruments. Now to the right, the block diagram deals with the second part of the design, which is defining the relationship between the controls and the indicators. If you right click on the block diagram, you will get a different palette, function palette, and it contains hundreds of different kinds of functions under different subcategories that will help you build the logic between the controls and the indicators. So let's build a small multiplication VI where user provides two numbers and the program returns the multiplication value of those two numbers. So we need two controls and one indicator. To do that, right click on the front panel, go to Numeric, and here you will find Numeric Control. Click on it and click once again on the front panel. This is how you place an item on the front panel. I'll do it one more time and one more time, but this time we need a numeric indicator. So I have two controls and one indicator on the front panel. You can rename each of these items by simply double clicking on the label and typing in your desired text. You can select an object, click and drag to any position on the front panel. As you've already noticed, for each item that I place on the front panel, I get a corresponding terminal with the same name on the block diagram. Let's assign the logic between these terminals. Now I'll right click on the block diagram, go to programming category, and in there I'll go to numeric and click on multiply function. Click once again and drop it on the block diagram. If I hover my mouse over here, you can see it automatically changes into a building wire icon. See? And through this icon I can connect or wire two terminals together. You click on the terminal, Then again click on the other terminal that you want to connect. In this case, the first input terminal of the multiply function. It turns solid and the connection is done. Let's do the same for the second number, and this output goes to the input terminal of the indicator. Now the connection is done. Enter two numbers in your controls on the front panel. And then you need to run the program. The run button you will find on top left corner here. You click run and you get your result in the indicator icon. That's simple. You can change your inputs. You click run again, the indicator gets updated. Saving a VI is the same process as in all the other applications. You go to File, click on Save, choose your location, give it a name, and save. That's it, your first VI is done. Let's build one more VI to explore few more concepts. This time a temperature conversion program that converts Fahrenheit temperature values into its Celsius values. If you remember your chemistry class, the formula for it is F minus 32 multiplied by 5/9 give you Celsius value. So let's create a new VI, put the windows side by side, and take a control on the front panel. But this time, let me take a fancier control, a vertical slide. You can find it under the control palette, under Numeric, here. Click and drop it on the front panel. If you left click on the control, you will get 6 corner nodes, these blue nodes. You click and drag on these nodes to increase the size of the control. Now for the indicator, let's take a temperature thermometer that you will find under the same subcategory. Click and place it on the front panel, and let's also increase the size of it. Because each one of these are analog, it is always helpful to create a corresponding digital display. To do that, right click on each one of these items, go to visible items, and select digital display. I do that one more time and I have a digital display for each one of my control and the indicator. Now let me rename these things. Input temperature in Fahrenheit and output in Celsius, and also increase the size of these texts a little bit. You can also change the scale of these controls by simply clicking on one of these limit values and type in the new value. Let's make it 200. Now right click on the block diagram, go to function palette, go to numeric, pin that window, drop 3 items, multiply, subtract, and divide. The first input terminal on the subtract function comes from the Fahrenheit value. And for the second input terminal, I need a constant value, 32. To get that, I right click on the second terminal, go to create, select constant, and type in the value 32 in there. For divide function, I need 2 constants as input. So I repeat the same, right click, create constant, type in 5. One more time, right click, create constant, type in 9. And the output of these two goes to the multiply function, and its output will give it to the thermometer indicator. The connections are done, and now you can give different Fahrenheit values and click run and see its corresponding Celsius values on the indicator. One important side note here. In LabVIEW, the program flow depends on how you wire things together. That is, this multiply function here will not execute until it got its data from the previous functions, in this case the subtract and the divide function. One way to visualize this is through this button on the top called Highlight Execution. You click on this and it may slow the program a little bit, but it'll show you how the data is flowing through the wires. So let's highlight that, run the program. Now you can see the multiplication is waiting for the data to arrive at its terminals from its previous functions before it executes. This is called data flow programming. Now we have covered quite a lot of things in this lecture. Before we conclude, one last thing. You see, instead of forcing the user to click on the run button every time he inputs a new value in the control or a new Fahrenheit temperature value, one efficient way of programming in LabVIEW is placing the code under a loop. We generally use a while loop for that. While loop, you can find it in the function palette under the subcategory structures. You can click on it and drag it around the code in the block diagram. So everything that is within this border will loop until a particular condition is met. That condition is defined by this icon here, called a loop condition. Right click here, select create control, and it puts a stop button on the front panel. See? Let me bring that stop button to the middle, increase its size a little bit. And now if you run your program, the code will continuously run in a loop until the stop button is pressed. See, that is the loop condition. Now if I change the Fahrenheit value, and because the program is still running, the output updates simultaneously. I change values and I can see the output updating. And once I click on the stop button, the loop ends and the program terminates. We will see about this while loops in more detail in the subsequent lectures. So that covers up the general introduction to the LabVIEW programming environment and creating your first simple virtual instruments.